Welcome back to this statics video in which we are solving the truss in problem 5.7 from the textbook. We are very nearly done with this truss. We have found all of the forces and all the truss members with the exception of one, this diagonal member between C and B, which means we either need to investigate joint B or joint C in order to complete this truss analysis. Now at joint C, we have the externally applied load plus 1, 2, 3, 4 framing members, truss members framing into it, for a total of 5 forces. And up here at B, we have the externally applied load and 1, 2, 3. So that's a total of 4 forces. So for that reason, I think joint B will be the simpler option to analyze. So let's draw our free body diagram of joint B. We have the 100 kilonewton externally applied load in the downward direction. We have the vertical member BD, we have the diagonal member BC, and we have the horizontal member AB. We found earlier that the force in member AB is 10 kilonewtons. And we found that it is in compression, which means it is pushing out in both directions. So it's pushing against joint B, so it's going to the right. The force in member BD is 113.3 kilonewtons. And it was also in compression, which means it is pushing against the joint. It's pushing both up against joint B and down against joint D. And that leaves this member BC, or CB, as our only unknown force. And once we solve for that, then this truss will be completely analyzed. We also know that the angle that that diagonal member makes with the horizontal is 53.13 degrees. So if we were to take a guess at the sense of BC, we can see that in the vertical direction we've got 100 kilonewtons pushing down, but 113.3 kilonewtons pushing back up. So currently the upward force is greater than the downward force. And we need for the sum of all the vertical forces to equal 0. We need them to all cancel out. So this 100 kilonewton force needs a little help. We need for this diagonal member to be in tension, pulling the joint down, pulling away from joint B. So if this member is in tension, it's going to be pulling away from joint B and also pulling away from joint C. So we can now solve for the unknown force BC by really summing in the x or y direction. And so let's do both. That is a good way to check our answer. We can first start in the x direction. We know that we have positive 10 kips to the right. Not kips, but kilonewtons. And that has to be resisted by the horizontal component of force BC. So that's going to be BC cosine of 53.13 degrees. So if we solve for BC, it is going to equal 10 divided by cosine of 53.13. So that gives me 16.67 kilonewtons. And that's our final unknown truss member. So this truss analysis is now complete. We have found all 1, 2, 3, 4, 5, 6, 7, 8, 9 truss forces. But it's not a bad idea, and it wouldn't be too difficult to at least sum the forces in the y direction at this joint B to make sure that, or at least give us a little bit more confirmation that everything we have done so far is correct. So if we sum the forces in the y direction, that's going to include our positive 113.3 kilonewtons minus 100 kilonewtons, and then also minus the vertical component of BC, which is going to be 16.67 kilonewtons times sine of 53.13. So if we've done everything correct up until now, the sum of these three vectors should equal 0. So let's see what the sum of forces in the y direction really does equal. When I put that into my calculator, I get negative 0.036 kilonewtons, or 0.0360 kilonewtons. So that, I would say, is close enough to 0 when we're talking about externally applied forces that are in the magnitude of 100. For our final check here to be less than 3 hundredths or less than 4 hundredths of a kilonewton, that's pretty good. That's a pretty reasonable margin of error, just simply due to rounding. In fact, we can move on to the next slide, in which we see, yes, this is a zero force member, which we found, 153.3, 50, 86.7, 30, 113.3, 16.7, 110. So yeah, all of our answers match up with the answers here in the answer key. And so an additional way, if we wanted to check our answers to be triply sure that we haven't made any mistakes, would be to come to this last joint C. This is the only joint in the truss we have not already analyzed. And we could sum the forces in the vertical direction and sum the forces in the horizontal direction. And for each of those summations, we should find that they sum to 0 or something very nearly 0, like in this previous joint B, where we found the sum to be less than 1/10 of a kilonewton. So that's it for truss analysis. I don't think it's a difficult process, but it is repetitive. It is lots of steps, lots of calculations, lots of opportunities to confuse sine and cosine, or leave out an externally applied load, or to just hit the wrong button on your calculator, or get a couple numbers mixed up. So really the key to doing these problems is to stay focused, be organized, write everything down. Don't try to do too much in your head or on the calculator. Leave a written trail of documentation of all your work, so that if there are any mistakes, you can go back and revise them. So as I said, that's it for truss analysis. After this, we will move on to frame analysis.